Alright, so let's start off where we left in the previous video, taking the same matrix that we had in the previous example. It's a 3x4 matrix, and now I'm going to show you how to convert this matrix, or for that matter any matrix, into a reduced row echelon form. Now what is a reduced row echelon form? It's any matrix which basically satisfies these two conditions, that every leading coefficient is 1 and it is the only non-zero entry in the column. Okay, so that basically means that for every row, the first non-zero element that you come across should be a 1. That's the leading coefficient, and for that particular column then all the other entries would be zeros. For example, if you have a 1 in the first row and first column, then for all the other entries in the first column you'll only come across zeros. Yeah. So the second rule is pretty simple and straightforward, that the rows with all zero elements, if any, are below rows having a non-zero element. So basically all the rows with all zero elements are at the bottom. Fine. So we have this matrix. I've executed this command and we get this beautiful little thing. So if you look carefully, you'll notice that the third row is actually the sum of the first and the second rows. So if you were to subtract the sum of the first and second rows from the third row, you'd actually get a row with all zero entries, and that's pretty good. That's a good step, and so that's what we'll go about doing. So let's do that, and you'll see how we are about to go about that. This what I've written here, A3, refers to the entire third row. If I were to write any other number here, it would mean the third row and first column. Now I'm simply referring to the entire third row. So I'm doing a row operation here, and now the third row, I'm going to convert it to third row minus the first row minus the second row. Okay, let's execute and see. Okay, as we expected, the third row has become composed of all zeros now. Let's move on to the next step. Let's try and get the 0 over here, so that later on when we convert this to a leading non-zero entry, we have a column with all zero entries below it. So for that, we'll have to subtract 1/3 of the first row from the second row, and that's what we'll do now. Yeah, so let's execute and see what happens. Okay, so we get a 0 over here, and these are all they might seem huge, daunting numbers, but don't worry, they're just fractions like 5 by 3, so nothing to worry about. That'll get sorted out and so on. So next step, what I think we should do is that what would be a good step to do at this stage? Alright, let's convert this to a 1 so that we get a leading 1 entry. Of course, I should have thought that earlier. So if we convert this to a 1, what we'll have to do is, I told you this is 5 by 3, so to get it into a 1, we have to multiply it by 3 by 5. So we will multiply the entire row by 3 by 5. So 3 by 5 into this row, and we get a 1, and see all those huge strange looking numbers have converted into simple whole numbers, and the only decimal integer is this one, 0.2. So now this has become the leading non-zero entry of the second row, but it does not satisfy the fact that it's the only non-zero entry in this column, because as you can see, there is this 1 in the first row. So we have to make that into a 0, and we'll use this row itself to convert that 1 into a 0. We'll say that row 1 is equal to, oh wow, where did I write R? It's supposed to be 1A. My bad, sorry. And that is a simple operation, row 1 minus row 2. And oh, again I wrote R. Yes, so we get zeros over here, right? Now the only thing left is to convert this entry into a 1. Right now it's a 3, so we'll simply divide that row by 3. 1 by 3 into thankfully I wrote A this time and not R. Yeah, so hopefully this will be fine. Let's just put a space for clarity. And perfect. We do get what we wanted. We have this matrix in row reduced form. Yes, all the leading non-zero entries are 1s and the leading entries are the only ones in the column. So this is your answer. And you could even verify it by using a built-in command, which is RREF, short form for Reduced Row Echelon Form. So if we have this matrix, I will go back to the previous statement, and then we'll just say RREF of A, execute. So we'll get exactly the same matrix which we got in the previous example by doing row operations, but that would be a good practice. And one more thing to note here is that the row operations that you follow for getting a matrix into this RREF form should not necessarily be identical to those followed by some other person. You do whatever comes intuitively to you, and basically you have to get to this stage where these conditions are satisfied. The method or the path you follow does not matter. Hope you enjoyed this video and learned something new. Thank you. See you next time.